Video number 4+11+, Energy and Gravity. Since quite a while, we heard about almost nothing but energy. The energy question is of basic importance for us and became a source of worries and conflicts as early as in 1974, after the first oil crisis. But what do we exactly mean by energy? Is there a general definition? Surprisingly enough, it is not the case. What is usually defined is the mechanical work of a force and its equivalence with other forms of this mysterious thing called energy. We shall now recall what it is about in 3 steps before asking about the origin of our energy. Then, we shall discuss the possibility of a huge hidden energy source that we might try to exploit in the future. Point 1. The mechanical work of a force. The notion of force is already rather mysterious in itself, to such an extent that many modern physics treatises avoid to rely too much on it. A force, in elementary mechanics, is what allows to move a material object, which in fact means to modify its velocity. But behind the force, another mysterious concept is hidden: the mass. A force is indeed the product of an acceleration by a mass, and in physics they are represented by proportional vectors. Acceleration is a purely mathematical concept in which only space and time are involved, but the mass is a physical concept which lies outside the purely mathematical framework, since mass pertains to matter, and matter is not a mathematical concept. The mechanical work of a force is a scalar quantity which usually evokes a conflict with other forces, either internal or external to the object on which the force is acting. The most elementary case is about lifting a weighting body. Here, the conflicting force is the weight. To lift a mass, capital M, by a height h, we need to apply a force, capital F, directly opposed to the weight P, equal mg, where g is the gravitational acceleration on Earth at the point where we are. The value of g changes slightly with altitude and even the position on Earth. When lifting, the lifting force produces a work W equal pH equals mgh. A similar situation occurs when one wants to move a heavy object on a solid and homogeneous horizontal ground. It is then necessary to fight against the friction force, which is the same at all points for a given object. The friction here depends on the contact surface of the mass, but not on the velocity of motion. So, the work depends only on the distance traveled, and the force capital F to be applied is constant. In the case of a straight route, we therefore still have W equal Fl, where capital L is the length of the route. Otherwise, it is more complicated, since the changes in direction of the velocity follow those of the force with some delay. In the 2 examples that we have just seen, the operator who moves the object, be it a man, a draft animal, or a machine, spends by definition an energy equal to the work W. Therefore, the energy has the dimension of mechanical work. More specifically, the dimension of W is mL2T-2, and this gives the formula for the dimensional analysis of the physical quantity called energy. Point 2. Kinetic energy. Actually, we cannot change the position of an object without imparting a speed to it and making the object pass from speed 0 at rest to a non-zero speed also spends energy. Again, by definition, this object acquires a form of energy called kinetic energy, a value capital E equal 1/2 of mv squared. It is clear that capital E corresponds to the same dimensional analysis formula as W. The factor 1/2 in the definition of kinetic energy is explained by integral calculus, the phenomenon is the same as the appearance of the factor 1/2 when integrating the function x to obtain 1/2 of x squared. To be convinced that the formula is correct, just imagine that we go from 0 at rest to the speed v by applying a constant form capital F during a time t. Therefore, a constant acceleration capital F over m equal gamma equal v prime of t, the time derivative of the velocity. As we start from 0, we have by integrating v of t equal t times gamma. The motion takes place entirely on a half line, and we can do the calculation with positive numbers without invoking vectors. The elementary work over a small time interval t plus dt is then f times v dt equal m t gamma squared dt. In this case, the work of the force capital F is the time integral of m t gamma squared dt, which gives exactly 1/2 of m v of capital T squared. Note that in fact, the result is independent of the force used. Its direction and intensity can vary arbitrarily. The work of a more general force, capital F of t, equal m v prime of t in the vector framework, is the integral in time of the scalar product v prime of t times v of t multiplied by the scalar capital M dt, which gives again 1/2 of m v of capital T squared. Point 3. Other forms of energy. Heat is a pervasive form of energy, which is actually a special case of kinetic energy, represented by the erratic movements or vibrations in situ of the atoms of matter. Chemical energy is perhaps the least obvious form of energy, along with electrical energy related to the motion of electric charges in a conductor. All these energies can pass from one from another by respecting the conditions which constitute thermodynamics and its principles. One of the most important principles is conservation of total energy for an isolated system. Point 4. The origin of energy. At the cosmic level, the origin of energy remains, and perhaps will always remain, a mystery of the well-known type, why is there something rather than nothing? But on our planet it is quite clear, at least within the framework defined by current knowledge. Indeed, the creation of stars, and in particular of our Sun, is considered as the consequence of the gravitational collapse of less hot structures, such as clouds of gas and dust. On our Earth, the constitutive materials come either from the Sun for hydrogen and helium, or from more massive stars having exploded a very long time ago for the other elements. Therefore, all the energy stored on Earth, except perhaps the electromagnetic energy that we do not know how to use directly yet, is the result of the work of the gravitational force. Besides, we use directly the gravitational potential energy to produce hydroelectricity. Behind gravity, there is obviously a form of energy, in a sense more fundamental than all the particular forms encountered on the planet. Even sunlight is a distant consequence of the action of this cumulative force over some billions of years. The question then arises as to whether we could not directly recover the energy of gravitation instead of exploiting it indirectly through the various sources of energy coming from the sun and the stars. But it seems difficult to do this without understanding the origin of the gravitational interaction between massive objects, a question which was the object of our previous video 7+. Point 5. A possible origin for the gravitational energy. In video number 7+, we spent some time recalling the Fatio-Lesage pushing gravity theory, which conjectures a kinetic origin for the gravitational energy, gravity being the consequence of shocks of tiny high-speed corpuscles with atoms and more precisely the nuclei. Electrons were not discovered yet in 1748. Disqualified for various reasons, and then somewhat forgotten in the last century, this theory has become again an object of research with different hypotheses on the nature of the impinging corpuscles, which in the sequel will be called, for simplicity, gravitons. In the framework of pushing gravity, it is possible to have an idea of the total energy of the gravitons crossing a given volume of space, or matter, which is about the same because even in a metal, the volume of matter is very negligible compared to empty space inside and outside the atoms, in 1 second. And the result is exceedingly high. Point 6. A small calculation. To compute exactly the incoming energy is presently impossible, since we do not know anything about the mechanical characteristics, velocity and momentum, of the gravitons. On the other hand, it is quite easy to obtain a lower bound under minimal hypotheses on the graviton flow by means of the following thought experiment. Let us consider the free fall on the Sun of an hydrogen atom initially at rest. We forget all other forces which might act on this atom to focus our attention on the effect of gravity, presumably due to the shocks of gravitons on the proton. The rotating electron can be forgotten here. It is very light and fast oscillating. The mass of the proton is about 1.7 times 10 to the power minus 27 kilogram. Since the surface gravity of the Sun is 274 meters per second square, in 1 second, the velocity of the atom passes from 0 to 274 meters per second. Therefore, a kinetic energy of 1/2 times 1.7 times 10 to the power minus 27 times 274 square joules has been transferred to our atoms by the gravitons. But actually, only one graviton out of 10 billions hits the nucleus, because the radius of protons is r0 equal 10 to the power minus 15 meter, and that of the hydrogen atom is r equal 10 to the power minus 10 meter. So for a fixed incoming direction, the proportion of efficient corpuscles is r0 over r squared equal 10 to the power minus 10. If we take into account the fact that only half of the gravitons is going upwards, and for those going downwards, the vertical projection is the only contribution to the fall, we see that the total energy, capital E of gravitons, crossing the volume of the hydrogen atom in 1 second is at least 4 times 10 to the power 10 times larger than the kinetic energy acquired after the fall of 1 second. Hence, capital E is greater than 2 times 1.7 times 10 to the power minus 17 times 274 squared joules, which after reduction gives E greater than 2.5 10 to the power minus 12 joules. On the other hand, the atom's volume is capital V equal 4/3 times P times 10 to the power minus 30 cubic meters. We conclude easily that E divided by V is greater than 5 times 10 to the power 17 joules per cubic meter. Summarizing, in the Fatio-Lesage pushing gravity framework, the total power of the gravitons crossing 1 cubic meter of space overpasses 500 million gigawatts, and it is probably much larger than 1 billion of gigawatts, since we obtain this number in 2 seconds of free fall. More generally, if we let the free fall last for a longer time, when we multiply the duration by a factor k, the calculated energy is multiplied by k squared, hence the power by k. This calculation is valid as long as the falling velocity is small compared to the speed of gravitons, that one being usually thought to be very high. Point 8. How to use the energy of gravitons. It is, of course, the interesting point, somehow reminiscent of the free energy possibly found by Nikola Tesla and never identified until now. Either we are able, for example, to devise a system allowing to increase the effect of gravity on a piece of metal in a cyclic way by guiding the atoms toward the graviton rain, or we discover a way to trap the gravitons passing by. The second possibility may require that we identify the nature of gravitons and find a way to interact with them directly. Point 9. Conclusion. I hope that you appreciated the contents of this rather optimistic video. For the time being, I wish to all of you an excellent new year.